Welcome to part 5 of repairing a Stuart Twin Victoria model steam engine. This is fitting a new silicone piston ring and a problem with the steam cylinder. Here are the piston rings. I bought several, that way I can stock up on them. And I got them from Blackgates Engineering as usual, details on screen. It's a simple job to fit the ring to the piston, but you must lubricate the piston thoroughly first for a couple of reasons. One is to give it a head start when it's in the cylinder so there are no dry spots, and the other is to make the silicone rubber slide over the sharp edges of the piston. While it's so easy to get at the cylinder, I'm removing the steam chest so I can look at the valve. And here is the slide valve sat on the port face. And this is the general layout of the steam chest assembly, with the gland nut and the valve spindle. It needs a bit of a clean up because it's fairly rusty, so I'm using some fine wet to dry sandpaper to do this. And I use it on the edge of a piece of wood to clean up the short corner pieces. Don't forget to use oil when you do this job. This is wet or dry sandpaper, and water's no good, it would cause more rusting, but oil is just as good and it makes the sandpaper cut much better. In this clip I'm cleaning off the oil residue with an old cloth. It's a good idea to clean parts up like this because you do not want any of the residue left because it makes very good grinding paste. And once the part is thoroughly cleaned, I put it back onto the cylinder, making sure that I don't forget the slide valve and making sure that I put the slide valve in the right way around. In this clip, I'm about to reintroduce the piston with its new piston ring to the cylinder. I've already cleaned the cylinder and I'm now lubricating it thoroughly before attempting to put the piston in there. The piston's a very good fit now. I'm really pleased with this. One thing's puzzling me though. It doesn't feel right. There's some compression. Now, how can there be compression because the steam port is open? When I pull and push on the piston, it's obvious that there's something wrong. There's a blockage in the steam port. Now, what could this be, I wonder? As it looks like I'm going to be manipulating this cylinder somewhat, I put a couple of nuts in place on a couple of the studs to hold the steam chest to the cylinder. And now, in an almost identical fashion to removing the rear cylinder cover, I'm removing the front cylinder cover. And luckily, once again, the small countersunk bolts are coming out very easily, which is not always the case, as I mentioned when I removed the rear cylinder cover. Using my hammer and sharp knife principle, as I've already outlined, the cylinder cover can be removed with ease from the cylinder. If you do this job, be very gentle with the hammer. I'm also now using the knife to make sure that the gasket isn't stuck to the cylinder cover. This is a top tip. It really is a top tip as well. And it only applies to cylinders that have the steam ports and steamways cast in. And having the steamways cast in I find to be a real bonus because you do not have to drill the cylinder down to the steam ports, which can be a very scary job if the drill bursts through the port face instead of into the port itself. These cast iron cylinders are sand castings, and sometimes the casting sand can be left behind. The casting sand remains in the casting itself, usually in the steamways. And the best way to get rid of this sand is to poke it out with some soft brass wire, as shown here. As this sand is in the steamways and it's mixed with oil, it's particularly difficult to get rid of it. It takes quite a while to poke it all out with the piece of brass wire, and this clip shows me finishing off the job with some compressed air. When using a jet of high pressure compressed air to do a job like this, it's a good idea to wear some PPE, personal protective equipment. Preferably a pair of safety glasses. Although to be 100% safe, it may be an idea to wear one of those old copper diver's helmets. Anyway, that's enough of that. It's time now to reassemble the cylinder. I'm showing this with the video speeded up to avoid the possibility of anyone slipping into a coma whilst watching it. This clip shows me rubbing the slide valve on a piece of very fine wet to dry sandpaper with a little oil. This is to clean up the face of the slide valve and make sure that it seals perfectly with the port face. The port face is in very good condition and did not need cleaning up, although one of the ports is malformed in the casting process, but that should be okay. I don't think it's going to cause a lot of problems. But with hindsight, I don't think I would have continued machining the cylinder. I would have sent the casting back for a replacement, but hey-ho, it should be okay. Time, I think, for a quick note about tightening very small nuts onto very small studs. These are 7BA studs and they will fracture very easily, and the last thing you want to do is shear one of them off. It's not like putting a cylinder head on a car. You have to take great care not to overstress the component. It really is a problem to me when I have to give a quote for repairing an engine, because you do not ever know what you're going to find. Obviously from experience and by listening to the engine I can tell generally where the fault lies, but you don't know about malformed ports, you don't know about sheared off bolts. On this engine there are no sheared off bolts whatsoever. When a customer brings an engine for me to look at, or sometimes I just get the photographs, it really is difficult to estimate the amount of work involved. And this problem is magnified if it's a complete steam plant that has a very old boiler with it. But at least it keeps me off the streets. That's it for now, thanks for watching and I hope you found it useful.